graphing calculators to solve systems because solving by graphing only really works if it's easy to tell where the two lines cross. If the two lines cross at like a really weird intersection point where it's not at a nice intersection of like 2.3, if it's at negative 2.37, you're not going to find that. So that's where the graphing calculators come in very handy. So if you guys could get out your graphing calculators, we're going to graph this system, which is x minus y equals 2 and x plus y equals 8. But as you know, there is a button on your calculator in order to graph lines. And what does that button say? Well, to enter an equation. Y equals. So you have to get this in a form that starts with y equals. And you can get it in the slope-intercept form. The slope-intercept form starts with y equals. So we have to get these. If we're going to put it into the graphing calcs, we have to get it into y equals form. So I'm going to take this first equation. And I'm going to start with you, Ava. How do I get that into a form which is y equals?
Subtract x.
Okay, then what happens? What do I get?
Negative y equals negative x plus 3.
Okay, am I done, Eva?
No. You have to divide negative 1 by this.
So what's my equation?
Y equals x minus 2.
Any questions on that equation? Okay. Denise, how do I get the second equation in y equals form?
You have to subtract x from both sides. Which will give you the y equals.
So what do you get?
Y equals negative x plus 8.
Am I done? Yes. Okay, so I'm going to write these down. And then I'm going to open up my graphing calculator. So there's a few things we want to make sure of before we go ahead and enter these in our calculator. First thing I want you guys to do is press zoom, and to make it so that our origin is in the center of the graph, because we've been zooming in on all sorts of weird spots, like in height versus steps, we were like up in the 60s for the x's. So we want to have it so our origin is right at the middle. So to get it like that, you're going to hit zoom 6, which is our standard graph. Also, you might have some random points plotted from doing all of those stat plots. So I'd like you to press y equals. Do you guys notice how I have one of my stat plots turned on right here? To get it to turn off, I'm going to put my cursor on top of plot 1 by pressing the up arrow and pressing enter. And then I'm going to go back down to put my cursor right in front of the Y1. And so now none of my plots are highlighted. These are all empty. And so I don't have any of those points that I entered in my tables turned on. So I shouldn't have any points graphed. Questions? So the first one I'm going to graph is negative x plus 8. So when you graph negative x, you have to press the negative button, which is below the 3, not the minus button. If you press the minus button, you're going to get an error. So negative x plus 8. Now you can put this in y1 or y2, it doesn't matter. Okay, the order of the equations doesn't matter. Now the second one is x minus 2. Now I'm using the x button, which is to the right of the green alpha key. So x minus 2. Eight.
What if when we do the 6s and 8s there?
All right, so once you have your two equations entered, what do you do to see the graph? Hit graph. Okay, so there are a few ways. Okay, now these calculators are very pixelated, so it's kind of tough to see where they overlap. Can anyone tell just by looking at them what point they cross? 5, 3. Now does 5, 3 work in both equations? We'll plug it in, Lisa. Now you can use the original form or the form that we solved for y, doesn't matter. I plug in 5 for x, do I get 3 for y? For both equations. I do, so good job spotting it. But again, sometimes it's not going to be whole numbers. So one way to do it is you can press the trace button. The trace button is the second one from the from the right. And trace button gives you a little beacon, and you can use the right and left arrow key to kind of walk along the line. And if you press the up or down arrow, it will flip between both equations. So you can just trace along your line. Now, is this pretty accurate?
No.
Yeah, I mean, you can get in the neighborhood, but we don't know exactly where they cross. Now I want to show you something. If you go to calculate, calculate is second trace. Second trace. What do you think we're going to use? Number 5, intersect. So everybody press 5 for intersect. Now you'll notice at the bottom there is a question. It says first curve question mark. So this is for, because you could put like 8 different equations in here, and they want to say, okay, you want to find an intersection, you need to tell me which 2 equations you want to find the intersection of. But you only...
I'm lost.
Okay, but you only put 2 equations in here. So if you only put 2 equations in here, all you have to do is kind of hit enter through the questions, because your calculator will automatically do the work for you. So you're going to hit enter, enter, enter. And it tells you the answer. So,
Wow.
so it's 5 comma 3. So this comes in very handy, especially when it's not a whole number, because it will find you the exact point of intersection, regardless of what it is. 5 comma 3. DJ?
What's the dash mark right up the top?
I think it is part of the line
Oh,
that has shown up on the other side of the word intersection.
oh,
So we have the intersection point. Also, I want you guys to go to your table. To go to your table, you press second graph.
oh.
Now, this is a table of values. Is anyone's table of values different than mine? Okay.
Yeah.
So where does yours start? What X value do you have?
Correct.
So I'm going to have you go to the table set. Do you see how table set you get to by pressing second window?
Oh. Yeah.
So have your table start at 0 and have your table go up by 1. Okay? So you can set your table to start at any value and to go up by any value. So now when you go to your table, which is again second graph, you can show the ordered pairs for all of the equations that you have entered. So, for example, when x is 0, y1 is 8, and y2 is -2. But look at this. When x is 3, do you see how both, when x is 5, do you see how both of these are 3?
Yes.
Okay, so if you look at a table, you're finding where they both have the same y values for that one x value. So when x is 5, y is 3 for both equations. In other words, this is the point that they have in common. They have 5 comma 3 in common. They both go through 5 comma 3. So that's another way to see the point in common, is by looking at the table. Yes?
Well, that's the one above it too, because it's 442. Does that work?
So for every, so this means for y1, the point is 4, 4.
Oh, yeah.
For y2, the point is 4, 2. Because this is x and this is y, this is x and this is y.
Great. Okay.
So that's a good question. All right, let's go on to do another one. Because this one we really didn't even need the calculator, or the calculator for. So let's do this one. Let's put both of these in y equals form. Okay, Nafi, how do I get this equation into y equals form?
So you change 5y to -5y, and then you subtract 4x from minus 4x, and you get 10 minus 4x. So it gives you -5y equals -4x, and then plus 10.
Okay,
And you divide that by 5. Negative. So then you'll get y equals -4 x plus negative.
okay, and the only edit I made there is because it's a negative over a negative, you make that a positive for this. Right? All right, Isaac?
You divide by -8.
I want you to read the equation carefully.
Oh, yeah.
Just add y and y both sides.
So Isaac's bringing the 10y over to the left.
And then add -8x.
Add negative 8x. So this is a negative 8x.
Add 8x.
Okay. What's next?
30 divided by 10.
What do you got?
You get y equals 4 over 5x minus 2.
4. So it's the same order? No, because I didn't. Minus 2, minus 2.
What does that mean?
It's
It's on top of each other. So if they're on top of each other, what do we say?
no. Depending.
Dependent. And how many solutions are there?
3.
Yeah, dependent and infinite solutions.
Yes.
So those 3 dots mean therefore they're the same line. So we can graph them, but it's just going to be one line right on top of the other line. So good luck. All right, questions on that one?
So if you get, like, before you solve it, if you notice that they're both, like, equivalent, like, as in, like, 4 times 2 is 8, and 5 times 2 is 10, and 10 times 2 is 20. Would you be able to just answer it?
If you can figure that out without putting in y equals 4. But that's tough to spot, so just be careful. A little negative makes them a different line. Okay, so let's look at page 249, number 72.
Do you even know what it says?
No. All right. All right, can I have a volunteer to read number 72? All right, Brenda.
Actually, no,
Oh.
maybe this isn't a bad idea. I'm not even going to teach it. Oh, anyway, there you go. 72. Equilibrium price. A manufacturer plans to supply Y units of its model 1020 PCD player per month when the retail price is $P per player, where Y equals 6P plus 100. Consumer studies show that the consumer for what number of
Consumer demand, so you're at the top.
Oh, I am. Oh, my bad. For the model 1020p is Y units per month, where Y equals negative 3p plus 910.
Okay, so let's fill in the following table. But you know what? I don't want to do this by hand. So I'm going to use the calculator. So the first equation in the table is, or the first thing in the table is supply. So it says that a manufacturer plans to supply. So the supply equation is 6p plus 100. So under y1, I'm going to type in 6x plus 100. So this is supply. And then the demand equation, and you guys will learn all about supply and demand in econ, which you'll take your junior year. The demand equation is negative 3p plus 910. Okay, so the calculator will calculate all these for us, and since we have a table, we might as well use the calculator table. So if we go to table, just keep in mind Y1 is supply and Y2 is demand. So if I go to table, I'm going to recopy these. Let me try yours over. Here's supply, here's demand. So what do you think? We need to get 0, 50, 100, 300. Now you can use the up or down arrows, but personally, I would rather just change the table settings. So let's go to table settings. So we're going to go to second window. So do you think it's okay to start at 0 still?
No.
Don't I need to know the answers at 0? Look at the table in the book. Yeah, I need to know at x equals 0 what it is. But what should I go up by? 50s. Good, because the next one I need to know is 50. So then I don't have to press the down arrow 50 times to get to the next thing. Okay, now go ahead and go back to the table. So second graph. Now you can very easily fill out your supply and demand table. So if the price is $0, you're going to only be able to supply 100 of them, because you're not bringing in money, but the demand's going to be really big. If the price is $50, you have this supply, this demand. $100. So you can see how, as the price goes up, they can make more, but the higher the price, people are going to want it less. It's like the iPhone X, with $1,000 being the price tag, the masses are not going to want to buy it. Which I speak, I'm hedging myself a little bit because people are buying it, but the masses are not buying it. Some people are, but not the masses. But you can see the more price here, the less the demand is, so less people are buying it. Like, I buy Cheez-Its. My kids love Cheez-Its. But when Cheez-Its are not on sale, I don't. They're like, heck no. All of a sudden they go up. I'm like, you can save. I'll be back next week. So when the price goes up, my demand goes down for them. I wait for the sale. So you can fill out the table for 0, 50, 100, and 300. Part B says use the data to graph both linear equations on the same coordinate system. And so what we're going to do is graph it, but let's just press graph and see what happens. Why not? Yeah, my zoom is. So look, all this action is happening between 0 and 300 for my x's. And my y's are going up to almost like 2,000. So let's go to the window, not literally, but in the graphic calculator. So let's do x between 0 and 300, which represents the price of CD players, which is what we used to have to buy. And we can have the scale, we can go up by 25 or 50. And then the minimum supply and demand, let's just go 0 to 2,000 here. Okay, hit graph.
Whoa.
Yeah.
Okay, so here are our two supply and demand graphs. And I just labeled them because. And then it says, what is the price when supply is equal to demand? Because you'd like supply equaling demand, because if it doesn't, you're either gonna run out, where they're gonna have a bunch of people that want these CD players, which were well before your time, but your parents probably still have CDs sitting around their house, so, and they may still have a CD player in their car, so they're still around. But they used to be very expensive, now they're like nothing, because nobody buys them anymore. But ideally, you'd want supply and demand to be equal, so there's not a whole bunch of inventory left over, and so they have enough so that if people want to buy them, they can. So that equilibrium point is where supply and demand are equal, so that there's not a bunch of inventory left over, and so that people don't want to buy them and can't get them. So that's right here. So let's calculate it. So what do we press?
Second and trace.
Okay. Which one?
5.
Okay, and how many times do we have to press enter?
3.
1, 2, 3. Okay, so it looks like at a price of $90,
Second for
ah,
Oh, sorry.
you have second for you get a five. You practice. Okay.
okay, so it looks like if they set the price of the CD players at $90,
Okay.
supply and demand will be equal.
No, I missed it off.
Good deal.
All right. Any questions? All right, there you go.
Thank you.